Friends, welcome to the tutorial series on network analysis made simple. In this tutorial, previous year gate questions on network analysis are solved. Emphasis on thinking process and strategy is the highlight of this series. I prefer to take you through the known to unknown, which makes the learning easy and enjoyable. I hope this tutorial ignites some of your thoughts. Let's go ahead. Friends, first let us solve question of GATE 1993. In this question, two cascaded networks are interconnected through three registers as shown in figure. This question can be solved using only Kirchhoff's current law and Ohm's law. You know that Kirchhoff's current law is applied to a junction point in the network, but it can also be applied to cascaded networks. It states that the sum of the currents entering any cascaded network is equal to the sum of the currents flowing away from the network. Further, hope you know that current in passive element flows from positive to negative. Now, according to Ohm's law, current of 10 divided by 5 equal to 2 ampere enters the network N2 as shown. Similarly, current of 5 divided by 1 equal to 5 ampere also enters N2. According to Kirchhoff's current law, applied to a cascaded network, current of 2 plus 5 equal to 7 ampere enters N2. So, 7 ampere current should leave N2 as shown. Therefore, voltage across 15 ohm resistance equal to 15 into 7 equal to minus 105 volts. Hence, option A is the correct answer. Friends, next we shall solve another question of GATE 1993. It is given that the resistors are linear and the sources are ideal. Note that this question can be solved only using Ohm's law. We know that in a linear resistor, phi relation is linear, meaning as voltage across R increases or decreases, the current through it correspondingly increases or decreases, resistance being constant. Further, if R increases, correspondingly I decreases and vice versa. So, if V is the voltage across R, then according to Ohm's law, I is equal to V divided by R, and voltage across R, VR is equal to I into R volts. Now, if the resistor values are doubled, resistance value will be 2 times R ohms. Current in each resistor will be I divided by 2 amperes. Then voltage across the resistance will be I divided by 2 into 2R equal to I into R volts. We find that even when the resistance values are doubled, voltage across each resistor will remain unchanged. Hence, option D is correct. Friends, next we shall solve GATE question of 1997. In this question, we are required to find the voltage V in the network shown in figure. The answer is straightforward. Observe that 10 volt source is connected directly across the terminals. Hence, V is equal to 10 volts. So, option A is the correct answer. Friends, next we shall solve another question of GATE 1997. We are required to find the voltage V across 3 ohm resistance of the network shown in figure. The question can be solved by using only Kirchhoff's voltage law. Observe the network. 4 volt source is directly connected across 2 ohm resistance. So, By writing the Kirchhoff's voltage equation for the loop, we get minus V plus 4 plus 4 minus 5 is equal to 0. By solving, we get V is equal to 3 volts. Hence, option A is the correct answer. Friends, next we shall solve yet another question of GATE 1997. In this question, we are required to find current I4 in the circuit shown in figure. The solution is based on Kirchhoff's current law. Observe the network. There are 4 junction nodes A, B, C and D and 7 branches. To junction node A, 3 branches. To B, 4 branches. To C, 3 branches. And to D, 4 branches are connected. Observe the junction node C, 2 branch currents are known. Hence, I5 is equal to I2 plus I3. By substituting the values, we get I5 is equal to 7 amperes as shown. Now, observe the junction node B. All branch currents except I6 are known. So, I6 is equal to I1 plus I2 minus I5. By substituting the values, we get I6 is equal to 1 ampere. Now, observe the junction node D. All branch currents except I4 are known. Hence, I4 is equal to minus I0 minus I6 minus I3. By substituting the values, we get I4 is equal to minus 12 amperes. Hence, option B is the correct answer. Friends, next we shall solve GATE question of 2000. In this question, we are required to find the value of voltage E. The solution is based on Kirchhoff's voltage equation. Observe the network. Understand that it is a part of the network. V1, V2, 0 volts and 10 volt terminals are junction nodes. Other branches of this network are not shown here. 0 volt junction is at ground potential. Note that V1, V2 junction nodes potentials are not known. Understand that positive terminal of 10 volt source is connected to that junction and its negative terminal is connected to the ground potential. So, by writing the Kirchhoff's voltage equation, tracing the circuit from the ground potential node, we get minus 1, minus E, minus 5, minus 10 is equal to 0. Hence, E is equal to minus 16 volts. So, option A is the correct answer. Friends, next we shall solve question of GATE 2006. In this question, we are required to find the value of R in the circuit shown in figure. Only by using Kirchhoff's voltage law and current law, the solution can be found out. Observe the network. The network has 4 junction nodes, 6 branches and 3 independent loops. Let I be the current through R. The current in 14 ohm is equal to 10 minus I amperes. Current through 1 ohm is equal to 5 plus I amperes. Observe the junction node B. By applying Kirchhoff's current law to junction node B, we get current in 2 ohm is 10 minus I plus 5 plus I equal to 15 amperes. Now, by writing Kirchhoff's voltage equation for loop 1, we get 100 minus 14 into 10 minus I minus 15 into 2 is equal to 0. By solving, we get I is equal to 5 amperes. But voltage across R, VR is equal to 100 minus 40 equal to 60 volts. So R is equal to VR divided by I. By substituting the values, we get R is equal to 12 ohm. Hence, the option D is the correct answer. Friends, finally, we shall solve question of GATE 2012. In this question, given VA minus VB is equal to 6, we are required to find VC minus VD in the network shown in figure. Observe the network. The network has 4 nodes identified as VA, VB, VC, and VD. But in addition to it, it has another 2 junction nodes as shown. So friends, the network seems to be complicated, but a bit of careful observation and thinking for a while, we can arrive at a very simple solution. See that it is given VA minus VB is equal to 6. But VA minus VB with any other reference node divided by 2 is the current flowing through that branch. By substituting the values, we get current through 2 ohm is equal to 3 amperes in the direction shown. Now friends, let us look at the given circuit in a different angle. The circuit can be viewed as though two networks as cascaded as shown. Then, applying the Kirchhoff's current law to a cascaded network, we find that 3 ampere current enters into, hence 3 amperes should leave into. Now, by applying current law, we find that current through 1 ohm will be 5 amperes in the direction shown. By writing the Kirchhoff's voltage equation for the branch, as explained earlier, with respect to any other reference node, we get Vc plus 5 minus Vd is equal to 0. Hence, Vc minus Vd is equal to minus 5 volts. So, the option A is the correct answer. Friends, in this tutorial, we learned to apply Ohm's law and Kirchhoff's laws to solve seems to be complicated problems. Though gate questions seem to be complicated, their solution will be simple. For that, we need to apply our mind, understand the network connectivity, analyze the given data to arrive at a simple solution. Friends, I hope this tutorial has ignited some of your thoughts. If so, please forward your feedback and suggestions to my email. Thank you for watching this video.